We have a data definition for natural numbers, or natch, that we made out of whole cloth. And now we saw the template, and now we're going to write some functions about it. A side note, by the way, the purpose of this lecture is not to say, hey, you need to do this in your own language. You might sometimes use a programming language that doesn't have natural numbers built in. No, that's not what I'm talking about. It is to show this approach of the data definition and this data-driven way of deriving the code, the union type, and the union type that might have a variant that is self-referential, and the power that gives us. And we're going to have several things. This technique will generalize to trees and other data structures. So this is just another example, more practice at getting this paradigm down, and an interesting new way to think about numbers and what they really are. Okay, so we had up in the very top, we have our data definition for a natch. It's either a Tixunia representing 0 or its make successor of a natural number. We had the struct that we defined for it. Then we had the template. We have our data definition as a union with 2 variants, so we have a cond with 2 branches. One of those variants is a struct with 1 field, so we go ahead and pull out that 1 field. We think about what type it is, a natch, and we sort of say, hey, let's put the natural recursive call in there because this function wants to consume a natch. Okay, so here's the first function we're going to write, and it's going to be string times. String times, here's a good example. String times of quattro and meow is going to return meow, 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 meow. Okay. Now when I say quattro, remember quattro is just shorthand identifier standing for make successor of make successor of make successor of make successor of Sunya. So string times of that thing with meow is going to give us back meow, 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 meow. Okay. So let's go ahead and write string times. We have the signature, takes a natural, and a string returns a string. We have a purpose statement here. Let's go in and remove the stub version and start writing this out. Okay, so string times is the name of this thing here. Let's look at the 2 variants. If I have 0, 0 times any string is the empty string. In fact, we saw up here we had some cases where 0 times meow was the empty string. Also, the other set of test cases, by the way, is that the empty string times anything gives you back the empty string. So you have our tests covering that, but fair enough. 0 times any string is the empty string. Okay, 0 copies of that string. Okay. Now we have string times. We pass it the previous number. So it's kind of weird. I think of the getter as being, reach inside this natural number I have and reach inside to get the previous, the predecessor to this natural number. Okay. So that's what this gray part is, the preceding number. Call string times on that. Of course, string times takes 2 arguments. Gosh, I want to make 4 copies of meow. I can take the 4 and pull out 3. So string times of 3 and what word would be helpful to me? Hey, string times of 3 and meow would be kind of handy. So I'm going to do the same word that I was given. Okay. And now how do I combine string times of 3 and meow to get string times of 4 and meow? Oh, I just do a string append of 1 copy of the word to the result of the recursive call. Let's see if that actually works. Do all this, get my parens right. Okay, save it, run it, and I got my parameter name. I was using my template, used a generic parameter name. I decided that the name word was a little bit more meaningful, so I called it word in this function. Let's go ahead and make sure that I do the same thing here. Oh, sorry, I called it n. N, N, N. Okay, now let's see if I got it right. Okay, and these tests all failed. Some later tests failed. These tests all passed. 14 of the 30 tests failed. 16 passed. The ones that failed are ones that are coming up for the next problem. Okay, so great. We have an example of writing string times where we didn't actually use numbers ourselves. Just interesting. Now, of course, you're like, well, but Gee, Barland, you're relying on string append and strings being built in. But remember, strings can be viewed as a list of characters, and we can do it all with lists and our list processing that we already know about. So, okay, next function, let's try one more, add. I want to be able to add two numbers, and here's some examples. If you add uno and dos, you should get trace. Remember, these are just the names standing for add of make successor of Sunya with make successor of Sunya, and you should get make successor of Sunya. Okay. Whew. So we'll go ahead and try that. Here's another one, add of trace and cincos, giving ocho. How should we do it? Let's go and see if we can copy the template here. Copy, go down here, paste. Okay, my recursive function name is called add and not that. And I'll recur on the previous number. It takes two arguments. This is an example where I actually have two of these union types coming in, two natural numbers. I'm going to return a third natural number. I'm going to just go ahead and recur on one of the two rather than look at all four cases of both natures simultaneously. It turns out that's enough for this problem. Okay, because what if, I'll look at m. What if m is 0? Well, if 0 plus n is going to be always n. So if you give me, if m is 0, then my answer is just the other number. Okay, great. What about this? I want to go ahead and I have the predecessor to m, so I have n minus 1. And I want to add that to something. Hey, if I add m minus 1 to n, okay, then this is going to give me m minus 1 plus n in my thinking, in my interpretation. That's m plus n minus 1. I want to get m plus n. Hey, just take this and give me the successor of this. Add 1 to it. How do I add 1 since I'm not really using numbers? I make a successor structure. I wrap it in another layer of successor. So my answer is going to be make successor of that recursive call. Okay. How much did I put in here that is not in the template? Just the word make successor. With string times, how much did I add that wasn't in the template? It was just a string append and one copy of the argument. There, it's a parameter. Okay, let's go ahead and save this, see if it runs. And hopefully everything's good. Now 23 of my tests have passed, and the ones that haven't passed are up in line 150, so looking ahead. Okay, cool. Now, like I was saying, the purpose of this is not to say you're going to have to program in a language that doesn't have natural numbers. That's ridiculous. But it's showing the power of this. But now, this does tell us how we can process, in a language that does have natural numbers, how to process the natural numbers in a way that follows the natural shape of the data. Because this is the shape of the data. This whole idea of a 0 and a successor of a number. It's just that rather than, since they're built in, I don't need to actually make a successor structure. If I want to go ahead and add 1 to a number, rather than say, hey, I'm going to call make successor on that thing to add 1 to it, I'll call a built-in function called add1, or 1 plus whatever. Okay. And how do I pull, if I have a natural number, how do I reach inside to pull out the one field that's inside of it? Well, I'm going to say that's just like if I had a real int in my language, that's just subtracting 1. So instead of saying pulling out that field, I'll call it sub1. Okay. And rather than asking if the number is 0, I'll just check if it's equal to the actual built-in int 0. And rather than asking if I have a successor structure, I'll say, hey, do I have a positive natural number? Okay. So let's go and give that a try. So the last function we'll do, but this time we're doing it with the built-in numbers in my language, not my concocted nat structure, okay? Okay, and so the function is going to be countdown. Countdown of 2 returns a string. 2 dot dot space, 1 dot dot space, blast off. Okay, so how do we write countdown? Well, we have test cases. What is countdown of 0? There's no numbers dot dot, it just blast off. Okay, so let's go ahead and copy paste the template. Oh, I'm not going to use I'm going to change the template so I don't actually use those structs. Rather than say is 0 question mark, I'm just going to ask 0 of, and I'm calling it n, so I'll call it again n here. Rather than say, do I have a successor structure, I'll say, hey, is this a positive number? A positive natural number? Okay. I'm taking in a real natural number, going to return a string. Countdown, I'm going to call countdown. And again, rather than pulling it to pull out the natural number that's inside n, I'm going to think of 1 as a getter. Okay? So, oh my goodness, I'm modalized on film. Okay, so this is the template now. How do we go from here to countdown? What is countdown of 0? Oh, it's the string blast off. I copy and paste that for my... Okay. Otherwise, what do I do? Well, if I have countdown of 3, this design recipe gives me countdown of 2. Okay, countdown of 2 is 2 dot dot 1 dot dot blast off. I need to get a string that is that with something string appended on the front. So string append of a dot dot, and before the dot dot is the actual number. So number to string of n. That's the built-in conversion. Okay, and let's go see if I got that correct. Run that, see if our tests actually pass. Actual value 1 dot dot blast off differs from 1 dot dot space blast off, the expected value. Good thing that I had tests, because that caught my little bug that I didn't include the space after the dot dots. Okay, not intentional. This happens. That's exactly why we have tests, to guard against this sort of silly mistake in the specs. Okay, up to most things passing. Awesome. Okay, and now we have only one more function to do. This will be our very last one, using real numbers, another idea of processing natural numbers. By the way, you probably saw examples of processing Fibonacci. Okay, how to write the Fibonacci function, and they use recursion like this. They're following the natural data definition. Even for things like arithmetic, and this string thing here, we don't need a loop to say, hey, given 9, create the string 9 dot dot 8 dot dot 7 dot dot blast off. We don't need a loop. We can use the natural definition of natural numbers. Okay, so the last idea is I want a function called boxes bullseye. What am I going to do? You give me a number n. I want to have a picture of n concentric squares with decreasing sizes. So if you say boxes bullseye of 2, I want a square of size 20, and inside that I want a square of size 10. Okay? And I guess inside that is a square of size 0, which is the empty image. Okay, so how can I write that? Okay, no problem. Boxes bullseye of n. Ask if n is 0 or positive. This is all the template here. The one thing that comes from the template is look at the predecessor of n, and go ahead and call boxes bullseye on that thing. Okay. What is the type of this? So the type of sub1 of n is a natural number. The type of boxes bullseye of sub1 of n, let's see, boxes bullseye signature, it's an image. So, okay. I have an image, I have the number n. How do I get the so boxes bullseye of 3, I have boxes bullseye of 2 already sitting there. It's the shaded thing I have. How do I build that to get boxes bullseye of 3? Oh, I overlay. I can see my test cases now help me. And I'm going to overlay a square. How big will the square be? Times of n and 10, outline blue. Okay, overlay that to that. Okay, and what was my empty case? Need the empty case. I need to return an image. What is an image that is a bullseye with 0 rings? That's just going to be the empty image. Okay, so go ahead and run and do that. See if it really works. Great. And I can try things like boxes bullseye of 30. Yeah, okay, awesome. So what's the point of all this? If you need to recur on a natural number, use the template, use the same approach. The getter is, hey, reach inside the natural number and pull out its predecessor. or check for 0. Those are the two cases and how to get the field that lives inside a natural number. And that's how we make programs that will terminate and don't loop forever. Okay, and again, the point of this is not, well, so I actually do write programs processing numbers like this in Racket. Notice we don't need a for loop. If you think that first part of actually designing the natural numbers ourselves and making our own struct and do it from scratch is kind of cool, yeah, then you're a little bit like me. Hey, go take a class called Foundations of Mathematics off in the math department. It's great, and they do exactly this. And you can actually write code for what they do in the class. We're going to go ahead and I mentioned down here, hey, if you make your own natch, you can now make a new data type called ints, which is maybe a natural number with a sign or something like that. Figure out how to do addition on that, okay? Make a new data type called rationals, spelled strangely. Oh, that was going to probably be a struct with a numerator and a denominator, yeah. You could even make a floating point that is a struct that has two rationals, the exponent and the mantissa. And now, without using any built-in idea of numbers, we can implement them ourselves in our language by using the right data definitions. That's the math geek side of things. The main point for you to take away in a computer science class is, hey, for processing natural numbers, yeah, check for 0 and otherwise recur on the predecessor of a number, the subtraction 1 of a number. Okay, great. Now that I've finished the video, the outside noise is all gone. Oh well, c'est la vie. Thanks.